Hey everybody, welcome to 7.4. So we're going to go over these problems right here. So we got graphing, there's graphing inequalities, solutions to two variable inequalities, and the key features in modeling. Okay, so we learn how to graph two variable inequalities and then solve two variable inequalities given a real world application by using a graph. So first one, so party food. Jason bought wings and hot dogs for a party. One package of hot dogs is $9. So we're just gonna underline that hot dogs is $9. Wings is $4. Jason's budget is 72. We need to write an inequality to express the food Jason can buy for the party. So first, you're going to set up categories to create an inequality, then solve for y and graph. Okay, so let's set up our categories. So we have hot dogs, we have wings, and we also have money, right? Those are three categories. So hot dogs is $9. So 9 per hot dog, so 9x. And our x-axis is packages of hot dogs too. Wings, we're going to add, wings is $4. So 4y, because that's our y-axis, right? So 4y equals $72. So that's our equation, right? 9x plus 4y equals 72. And then we want that to be an inequality. So we have a budget of 72, so up to $72. So we have to do less than or equal to $72. Now that is our inequality. That is our budget, $72. So it has to be less than that. So we need to graph this. Right? So this is less than or equal to budget of $72. That's why it's less than or equal to. Now we're going to solve, right? So we're going to solve for y. So solve for y. So 9x plus 4y is less than or equal to 72. So we're going to subtract 9x to both sides. First, always subtract that x on the left. Subtract 9x. So we have 4y is less than or equal to negative 9x plus 72. Then divide by the coefficient to everything. So we have y is less than or equal to negative 9 over 4x plus 72 divided by 4 is 18. So this is the inequality that we want to graph. And it's given that this is our y-intercept, right? Our number by itself, number next to the x is our slope. So we're going to use that to graph. So we start at 18 on our y-axis, which is right there. And then we're going to use the slope down 9, right 4, right? So the intervals on the y-axis goes by 2s. So 2, 4, 6, 8.5. Right there is 9. And then we go right 4. 1, 2, 3, 4. Now x-axis goes by 1s. Right, so negative 9, down 9, right 4, always to the right. So that's 1 point. And then we go down 9 again, right 4. And that's our second point. And then we make our line right there. So that's our line. And we want to do inequality. So we have to spend less than $72. So it's going to be less than or equal to. So we're going to shade underneath it, right? Less than. If it was greater than, we shade above. But we want all our answers to be less than $72. So that's why we shade below, right? And it tells you, right, any point below our graph will give a combination of hot dogs and wings that will cost less than $72 and stay within our budget. So possible combinations that we can write in here. So we pick any point in here. So here's 2, 4. 2, 4. 2 hot dogs, 4 wings will cost less than $72. 4, 2. That's another one. 4 hot dogs, 2 wings will cost less than $72. So any point within here, like 1, 14. 1 hot dogs, 4 packages of wings will cost less than $72. We can do all these points. Right, we get to this point right here, 6, 0, 6 hot dogs, 0 wings. That's another example. Cost less than $72. Stay within our budget. We can do this one on the line, 8, 0. So on the line is exactly $72. Here's another one, 4, 9 is exactly $72. 0, 18 is exactly $72. Okay, so anything on our line, $72 exactly. Anything below is less than $72, and we still stay within our budget. Okay, so that's how we use inequalities and why we shade, right? Okay, the difference is dotted line versus solid line, right? So less than or greater, if there's no line underneath it here, it's going to be dashed like that. If there is a line, it's equal to the line, so it's going to be solid. Okay, and then we shade if it's less than, we shade below, below. If it's greater than, we shade above, anything above our line. It's like 72, just like our budget. We want to stay below 72, we shade below. We want to stay above it, we shade above. Okay, so here's number 3 as an example. So first, we can already tell by our inequality, right? This is less than. So less than means we're going to shade below. If we want it to be less than. And then we also can tell, since it's not equal, it's going to be a dashed line. And then we graph. Right, so we're going to graph here. So this is our y-intercept. This is our slope. Right, our slope is in front of the x. There's nothing, but it's a 1, right, a 1x. That's our coefficient. So we start our intercept 2. We use our slope 1, always to the right, up to the right. So up to the right, up to the right. Right, so we always go into the right, either up to the right or down to the right. There. And then it's going to be dashed. So we make a dashed line, like we said. And then we shade below. So we're going to shade everything below here. And that's our solution. So any point in here, in shaded area, is a solution. Okay, so any point in there. Okay, next one. Look at our inequality again. This is greater or equal to. So because it's greater or equal to, this is greater, we're going to shade above our line. And it's equal to is going to be a solid line. Then we look at our y-intercept and our slope. Right there. So we start our y-intercept -3 on our y-axis. Our slope is 1/2. So up 1, right 2. Up 1, right 2. Up 1, right 2. And follow the pattern all the way. It's going to be a solid line. So we just draw a solid line. And then we shade above. So we shade everything above here. And that's our solution right there. All right, so the first thing we look at our inequality. Is it less than? We shade below. If it's greater than, we shade above. If it's not equal to, doesn't have a line, it's going to be a dashed line. If it has a line under it, it's equal to the line, so it's solid. Okay, so let's do number 5. So same thing. If we look at this, right? So y is less than or equal to. So it's less than or equal to. So less than, we're going to shade below. And equal to is going to be a solid line. And then we can tell what our y-intercept is, and then what our slope is. So our y-intercept is 2. Our slope is -5, so we're going down to the right. So down 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, so down 5, right 4 is going to be a solid line. Draw our line in here, there, and then we shade below because it's less than. So we shade everything below, right there. Okay, so the last one, first it's in standard form. So remember, we need to solve for y first. So we're going to subtract 3x first. So subtract 3x. So we had y is less than -3x plus 4. And then y doesn't have a coefficient, it's just 1, so we don't have to divide by a number. So now we have our inequality again is greater right? So this is greater. So greater than is going to be shade above, and then it doesn't have a line under it, so it's not equal to your line, so it's going to be dashed line. And we can tell what our y-intercept is, 4, right? Y-intercept equals 4. Our slope equals -3. So we start at 4. Our slope is -3 or -3/1. So we're down 3, 1, 2, 3, right 1, right? -3 plus 1. Down 3, right 1. Keep following the pattern. And it's going to be a dashed line, right? So dashed line through those points. And we shade above. So everything above this line, we shade. And that is our solution. So if it's in standard form, first you need to solve for y by subtracting your x value on the left to both sides, dividing by the coefficient. This one didn't have a coefficient other than 1, so we just leave it. And then we graph it the same way and shade. Okay, so moving on. So is -3, -5 a solution to the graph inequality? So let's look at where that is. So -3, -5 is here, right? -3 on the x-axis, -5 on the y-axis. So it's outside of our shaded area. So is this a solution? No. Not in shaded area. Okay, next one. 1, 3, right? So 1 on the x, 3 on the y is right there. So that is within our shaded area. So yes, it is a solution. Right? It is in the shaded area. Okay, simple. Right? If it's in the shaded area, it's a solution. If it's not a solution. So is phi 0, right? So phi 0, x, y. So here's phi 0 on our lines. Is that a solution? Right? So this one is a solid line, so it includes our line. So it is a solution. So this one's, yes, it is on a solid line. If it was a dashed line, it would not be a solution because it's not including the line. Okay, so last one. We're going to write an inequality representing by a graph. So just looking at this, we can tell, right? So right there, the y-intercept equals 3. We can tell what the slope is from getting from one point to the next. We went up 1, so positive 1, and then right 4 plus 4. So our slope is equal to 1 over 4, right? Because we went up 1, right 4. And it should be positive because we went up to the right. So we can just write our equation. So we compare it to y equals mx plus b. So we have y equals our m, which is 1/4. Next to our x, our intercept is 3, so positive 3. And then we want to write an inequality instead of equals, right? Because it's just not the line. So we're shading. So this one shades below. So you know it's going to be less than. And then our line is dashed. So it's not equal to our line. So it doesn't have our line underneath here like that. That doesn't work. That would be a solid line. So it's just less than. So we have y is less than 1/4 x plus 3. And that's how we create equations. Okay, so you can do the rest. Make sure you check your answers on the answer key and then set that up. All right, good luck.